What is up, amigos? Today we're talking about bouncing oblique shockwaves. So in the last couple of weeks we've gone through shockwaves, and 2 weeks ago we went through how shockwaves form in terms of the angle that they make. And so we know that if we have a disturbance, that all the flow gets caught up and then we get a certain angle. So let's say we have the flow coming in here and it's supersonic. So Mach number is 3 or whatever. It doesn't really matter as long as it's supersonic. And it comes along here and then it hits this little contraction here, so this wedge here. And now what's happening is that the flow is starting to be compressed and it can't move out of the way fast enough, so we end up getting a shockwave forming. And depending on this angle here, this will affect the angle of the shockwave. So let's say we get a shockwave like this. Now, upstream we may get we have supersonic flow. Downstream we may have subsonic or supersonic depending on the initial Mach number and this angle here. But we have a shockwave nonetheless. And what happens when it reaches this wall here? Does it just dissipate, or does it continue, or what happens? Well, this is actually quite an interesting phenomenon. So we have two things that are happening here that are going to affect the flow physics. The first one is that as the flow comes through, it's actually going to be directed up a little bit. And this is because we have this little wedge here that's kind of pushing the flow up. So the flow all along here is now getting pushed up. Now, when we get to here, the flow obviously can't actually go past the wall because the wall is a solid object. So the flow is getting directed up in this direction, but it can't go that direction. So what actually ends up happening is we get a compression forming here, and we end up getting another shock forming here, which is the reflected shock. So we can actually bounce a shock wave off of walls based on how much we are trying to push the flow up, and also how far this wall is from here. Now, two things to mention are, first, what happens to this shockwave? Does it just continue? Well, if the shockwave is strong enough and we have another wall down here, it will impact this wall, and again we get the exact same thing happening where we have the flow being compressed and now we might get another shock. Secondly, the further away this wall is from the shock, that's making the shock, so this wedge here, the weaker the shock will end up being as we get to this wall, and the weaker this shock will become. So for example, if we have a supersonic aircraft flying above us at 10 kilometers altitude or whatever, so 33,000 feet, and it's creating a shockwave, by the time it gets to ground, that shockwave has really dissipated in terms of its energy. So yes, the flow is still trying to be directed towards the ground a little bit, and the ground doesn't want the flow going straight into. Obviously, it wants to be more parallel to make a boundary layer kind of situation. So there will be a reflected shock, but because the shock is so weak at this point impacting the ground, the compression of the air there is very little, so this reflected shock becomes very weak. But if we have the aircraft very close to the ground, like 5 meters from the ground, 15, 18 feet, then we have a very strong shock impinging the ground, and we'll get a very strong reflected shock off of that. So that is how to bounce oblique shockwaves and why that occurs, and then how the upstream Mach number affects this resulting reflected shockwave. So if you like this video, make sure to like and click the subscribe button, and I'll see you next one. Peace, amigos.